Good morning, students. In this lesson, we had already seen nuclear radioactivity, artificial radioactivity, alpha, beta, and gamma decay, the properties of alpha, beta, and gamma rays. Today, we are going to see about an nuclear fission. Fission, F-I-S-S-I-O-N, fission. Fission means splitting up of nucleus. Fission means splitting up of nucleus. Then we are going to study about an fusion. Fusion, F-U-S-I-O-N. Fusion means fusing, joining up of nucleus. The nucleus, as we study in the radioactivity, the heaviest nucleus will start decaying the alpha beta particles. If you bombard, already it is so heaviest, if you bombard with small neutron, it split up into two small nuclei and with three neutrons. It is an uncontrolled chain reaction, and it is the basic principle of atom bomb. So we will see the definition of nuclear fission now. In 1939, German scientists Otto Hahn and F. Strassmann discovered that when a uranium nucleus is bombarded with a neutron, it breaks up into two smaller nuclei of comparable mass along with the emission of few neutrons and energy. This process of, see from this you have to mark the definition, the process of splitting up of heavier nuclei into two smaller nuclei with the release of large amount of energy and few neutrons is called as nuclear fission. Once again I am saying this definition, the process of breaking up of a heavier nucleus into two smaller nuclei with the release of large amount of energy and few neutrons is called nuclear fission. Example, the heaviest nuclei is uranium. Uranium mass is 235 and atomic number is 92. It is hit with a neutron, no atomic number with the mass 1, and it is bombarded or collided with the heaviest nucleus uranium and splitting into two smaller nuclei, barium and krypton, having an atomic number 56 plus 36. Together you will be getting a 92 equal to the mass of atomic number of uranium, and the mass is 141 and 92. Add this to two things, you will get 233. The remaining 3 is neutrons. The remaining 3 is neutron plus some amount of energy. Large amount of energy is released. The average energy released in each fission is 3.2 into 10 power 11 joules. Nuclear fission is pictorially represented in the figure. See the very big red color ball with the burning at the center, that is ready to split up, is a uranium nuclei. When it is bombarded with a single neutron, it is split into barium and krypton with the 3 neutron. This is your nuclear fission. Then fissionable material. The nucleus which is able to splitting into some other nuclei or emitting radioactive materials is called as fissionable material. A fissionable material is a radioactive element. All radioactive element is a fissionable material which undergoes a fission in a sustained manner. When it absorbs a neutron, it is also termed as fissile material. The splitting up of material, the ability of a material which is able to split is called as fissile material. All isotopes of uranium do not undergo nuclear fission when they absorb a neutron. For example, natural uranium consists of 99.28% and 0.72%, and of these two does not undergo fission. So only the uranium 235 with the 92 will undergo the fissionable process, whereas an uranium 235 undergo fission. Hence uranium 235 is a fissionable material, and uranium 238 is a non-fissionable material. There are some radioactive elements which can be converted into fissionable material. They are called an fertile material. The material which is able to split by Heating a nucleus is called as fissionable material. Fissionable material, the material which is converted, which can be converted, is called as fertile material. Uranium-235 is an fissionable material. Then uranium-238, thorium and plutonium is called as fertile materials. The next we are going to study about a chain reaction. What is a chain? Continuous. Chain reaction means continuous process. Here the chain means continuous process. Controlled chain reaction and uncontrolled chain reaction. The chain reaction which we cannot able to stop, it will be goes on, is called as controlled chain reaction. Uncontrolled chain reaction. The chain reaction it will be goes on, but you can able to stop it in a certain period, and wherever you want there you can stop it, is called as controlled chain reaction. You are not able to control the process, it will be goes on, is called as uncontrolled chain reaction. What we have studied in the nuclear fission is the basic principle for chain reaction. The uranium, once bombarded with a nucleus, is split into two smaller nuclei with the emission of 3 neutrons. This process is continuous, it will be goes on and then produce an devastating effect, that is an uncontrolled chain reaction. What is the principle of your atom bomb? The same fissionable material used in the nuclear reactor is controlled by using an cadmium rods. Using an cadmium rods, it will absorb the 1 or 2 neutrons which is emitted by the uranium. By absorbing the neutrons, the second and third process of fission, continuous fission, can be controlled and the energy is converted into electrical energy. In such a way, the same fissionable material nuclear fission reaction is used as an controlled chain reaction in nuclear reactor and uncontrolled chain reaction in atom bomb, producing a devastating effect. See this? A uranium nucleus, when bombarded with a neutron, undergoes a fission process producing 3 neutrons. These 3 neutrons in turn can cause fission in 3 other uranium nuclei. Then it will produce 9 neutrons. These 9 neutrons in turn may produce 27 neutrons and so on. This is known as chain reaction. Here you can mark the definition for chain reaction. A chain reaction is a self-propagating process in which the number of neutrons goes on multiplying rapidly, almost in a geometrical progression. Once again I am saying the definition. A chain reaction is a self-propagating process in which the number of neutrons goes on multiplying rapidly, almost in a geometrical progression. Two kinds of chain reaction. One is controlled chain reaction, another one is uncontrolled chain reaction. See, the controlled chain reaction can be achieved by absorbing the extra neutrons with the neutron absorbers, leaving only one neutron to produce further fission. Thus the reaction is sustained in a controlled manner, controlled safely. The energy released due to controlled chain reaction can be utilized for the constructive purpose. Controlled chain reaction is used in nuclear reactor to produce energy in a sustained and controlled manner. Uncontrolled chain reaction. In the uncontrolled chain reaction, the number of neutrons multiplies indefinitely and causes a fission in a large amount of the fissile material. This results in the release of huge amount of energy within a fraction of second. This kind of chain reaction is used in the atom bomb to produce an explosion. See, the first nucleus is an uranium that will produce a barium and krypton. 3 neutrons in turn hitting some other nucleus and produces some more neutrons, and see the 4 uranium nucleus and 4 splitted into 2 smaller nuclei with the 3 neutrons. We are just calculating leaving a 1 neutron by chance. Only the 2 neutrons hitting itself, it goes on multiplying. So till this we have studied chain reaction, fission reaction, uncontrolled chain reaction. Next we will be studying the critical mass and nuclear fission in next video.